Okay, hello everyone, I'm Xiaogao. In this lesson, we'll start refining the methods we need to use. Since the previous code was quite scattered, the main goal was for everyone to get familiar with the flow. Now we'll further improve the process of these methods. I'll directly provide the interfaces here. First of all, you definitely need to send a message to all clients within this container. So we have a method to send a message to a specified client. You just need to pass the serial. Connection ID, then we definitely have blueprint here. We said sometimes we need to disconnect a specific connection, or when we need to disconnect all connections. So we have these two methods. Right, this is still quite clear. So when we use it, we actually have an internal method to check whether the current connection is available. We just need to check what state it's in is currently in. Then we'll create them one by one. Let's create this one first. The method to send specified information to this client. So first we need to prepare a WebSocket. Then this code must be equal to 0. Then for this enum, it must be from server to client. This is also fine. Then it's data as this message. We can just put it here. This message is if you want to wrap another layer of JSON, or if you want to send some encrypted audio, video, or image data, that is all possible. You can just encode it yourself with basics for binary encoding. Then you can wrap another layer of JSON and it will be fine. Then at this point, remember we must assign our ServerConnection to it. Then the information of this struct we need. And we also need to find, so now we go into the container to find the information of the server link we defined. This is our data. Then after finding this link, we can obtain the client information if found, if not found. Then this interface is definitely, so you can add a check here or something. If it cannot be sent, we won't add it here. Okay, just leave it alone for now. Then this part can be further improved. Then just send this information directly. You can send it through this. This sending method is defined by us. Send it within the serial connection struct. It will automatically encrypt and decrypt the data. Split it like this. We need to make the upper level encapsulation clearer. Similarly, we also need to send multiple ones. So sometimes when we need to send all of them, we need to create the send all method. Actually, the previous part is the same. We have defined this data at this point. So here we will directly start iterating through the container. Because now, within all containers, this server connection link all need to be sent. That is to all clients. The link for all clients needs to be sent. Then for the values in all clients, we only need to retrieve them from the container. Just a getten. And we know here we will directly take this thing and send it. You see, because here it is, iteration, here it is, find. So pay attention, there is a value. So everyone needs to understand clearly. The sending ends here. So how do we recycle resources? As for recycling resources, this is exposed to blueprint. Actually, we have already written it. So before recycling resources, we need to perform an operation. The design here is a bit convoluted, but everyone needs to understand. That is to say, this needs to be divided into many types. One is client side, one is server side. As for something like this, that is obviously the case. The service means the server closes the client. Then you must wait for the client to receive it. Only then can you close it. You cannot just start by manually releasing it, right? So you cannot just start by directly calling our method to release it. That would be incorrect, because doing so would release it directly and the client would actually be unaware. Therefore, you cannot call it this way here. So it has been commented out here. That is how it is designed. You can make a note of this here, because after iterating on this part, I think this design is more reasonable. Then we go into this container, find the link we need to release. If we find this link, then we change a status to, meaning it is ready to exit, right? Because we are the server. So it is ready to exit the state. Then we give this information to. We just need to modify the enum. As for the action enum here, it actually refers to the server. Note that these two need to be distinguished. This refers to the state of the link. This refers to the state of the information. So this is the server asking your client to exit. Right, then you send this information to the server. We need to wait until the server receives it. Only then do we process this matter. Okay, so this part is okay. If the server does not receive it, then such a link is broken. Then we will have a heartbeat detection mechanism. The heartbeat will directly release it. So everyone doesn't need to worry. For example, if the client deliberately does not return information to you, then how do I release it? Because we release it through the heartbeat. Yes, Okay, then next to this connect, we need to close all these connections. Closing all these connections is actually quite simple. We can just call it directly like this, right? A for loop, then call this again. Actually, the way we wrote it above is also fine, but it's more or less the same. You can call this. It's completely fine for you to drop this, but dropping it directly on our end is also fine. Okay, after these four methods are written, we mainly have this method here. We check whether this link is in an available state. As for this state, first of all, this server must be available. The server must be available. Then we need to find this link, and this link, as long as it exists, we consider it currently available. If it does not exist, it is no longer available. This thing does not hold a blueprint. So this is how we determine availability. What is our criterion for determining availability? That is to say, as long as this link has not been destroyed, we consider it available. It does not mean that the link is in a normal heartbeat communication mechanism. Okay, this is for our use. This is not for user use. Okay, so after we have this thing, we need to be here. We need to be in our store to call this method, because as we mentioned earlier, when the server exits, you need to make sure all of its exit as well. Okay, then you might say if the server exits, for example, if the server loses power, right? Then the client hasn't received the exit command sent by the server. It's fine. The client has a heartbeat mechanism. The client times out. He just turned it off. So this point is also, basically, there's no problem. Generally, we don't really consider such extreme cases. That is someone unplugging the server's power on you, that kind of situation, or someone forging information for you, because this is all used on the internal network. Relatively speaking, we didn't design it to be that complicated. If you make it too complicated, you need backups, and you also need the 3-2-1 rule for this kind of data. This all becomes very complicated. There is no need to do so much here. Okay, so basically after we finish this part, after finishing, okay, let's come back here. Back to our information receiving part. At the receiving part, here we need to handle it. So it's obvious that this information is incorrect here. We consider this link to be the received information is unreasonable because its code is no longer equal to 0. Then we consider that we notify. We send a message to the client saying that you need to close it. So here we are. We need to call this method. We give it a message. We say you need to close it. Okay, then if this message is normal, we start processing. Before we remember to process the message, we previously had object. We had a closed bank. Closed band is directly released. So you need to distinguish this upper level count. This is just simply sending a message notifying that it needs to close, while here it is directly released. So you need to distinguish between these two interfaces. Okay, next we'll distribute this information. As for this information, because it has many layers, so here we must have a function. Just like when we wrote the HTTP server, you should still remember, we needed a message possess function at that time. We will handle which link sent what information. Now let's define this function, okay? Because this thing is another set. So we need to pick a better position. We'll write it down here because our design is all layer by layer. It's all good. Okay, when we process the information, obviously, we need such a function. Okay, this function, it mainly does a simple distribution like this, because here we have already confirmed our interface setup has been parsed successfully. Right, then we just directly based on this switch. I'll just copy it over here. We can just write it like this. It's also no problem. I will switch. This way, it feels more intuitive for everyone. Sweet. And then here, we need to bring up this action. Why do we use Mage? It's for convenience. Okay, this place, it doesn't seem to have a drop down. It didn't give us a one-click generation. That's quite annoying. Let's try again, because sometimes it can generate with one click. Sometimes it doesn't work so well. If it can't generate with one click, then forget it. It can be viewed now. We mainly want it to help us generate with one click. These enum-related things, we can directly place it here. I've pasted it over. We don't have these methods yet. Let's just leave it. Let's leave it here for now. We can comment it out. To avoid making it messy for you, this is actually based on our enum. Let's further process this information. First, the first and last ones don't need to be processed. That is, something like max or similar. Actually, you need to check here because it's possible that this thing is not what you want. So let's briefly explain. Then on the server side, the types it receives will only be those sent by the client. So it will only have these few types. It can be seen that this is the first time the client sends information over, notifying the server to initialize. This is their regular tick heartbeat. This is the user. We expose it to the user, expose it to Blueprint or other developers. They communicate through this. And this is the server requesting to exit. Yes, the server is requesting to exit. Then I misspoke. This is the client requesting to exit. Right. And what is this? This is us requesting to exit. Then the client allows us to exit. This part is a bit noisy. This is the client requesting to exit. The server allows the exit. So this part. These two parts are a bit similar. Let me guide everyone to write it out first. Let's write this first. That is, after our first successful connection, the client will actively send us a message. Just like when we do TTS. After our successful connection, we need to actively send the synthesized speech text to Zhongfei. Then Zhongfei will start sending segments of PCM data one after another. So the idea here is like this. Okay, then we will write this part next. Because these sides are all the same, I'll just copy it over. Copy this over. Copy this over. Because you see they are all the same. So I won't create them one by one. I've written quite a lot here for everyone. Okay, alright, let's write a bit more in this lesson. So when the server sends it for the first time, what information will it send over? This is what we have agreed upon. That is to say, first of all, we must find this link, because this link must exist. Alright, after finding this link, because when it sends it for the first time, the information it sends will definitely include its collect. That is, it will include its own link. Because this information is when it first comes over. Only then will he have this information. That is, he must send the first message. Only then do we have this. We obtain this information, then in our server connection, we click this link, because we will use it later. At this point, we can change our link to the tick state, because we have already received the client's request. Then we need to return a message to him. So what message do we return? We mean the type of message we return. That is, we have received your. That is, you are the client calling the server to initialize. Then the server tells you it has now been initialized. The connection has been initialized, and it gives you the server. Then it gives you the server's server connection ID. Then this collection ID is the one you sent over. We return it to you, so you can use it conveniently, so you can find it easily. Right. This is on its local machine. Only then can you find this connection. This is what we give them. This is on our server, this ID. Then we no longer need this data because we are only using an ID. Then at this point, we pass this data over, pass our link through it. After passing it, then at this point, we can call the blueprint. This is where we call the blueprint. We call the blueprint. We tell the blueprint we have a link coming in here after it comes in, and the client has already completed the first initialization. We have already recorded it. So this ID of yours, these two IDs are for you to query later. And the useful calling, we can then obtain this server currency ID. And manage and process sending and receiving messages, right? So if you want to define other information, you can then continue to define it during the second communication. Or the specifying whether it is instance A or instance B. Then it tells you it is instance A, you instance A. Now I will assign to you what level you need to open currently and what port you are currently executing on. You can then proceed with further communication, but this communication needs to be written outside. Don't write it inside this plugin. Why should it be written outside? Because this pool is written by us. It is a framework. You cannot modify the framework just to add a little something. You shouldn't change the framework because this project is copy A. Then your next project might be copy S, and that project clearly doesn't have copy A. If you insist on writing communication info for copy A, then after sending it like this, the server can receive our initialization complete message. Okay, good. So next now we enter the tick phase. In the tick phase, we have the server backend actively send information to tick. That is, our server only performs time calculations. So when this type is ticked by the client, Then how do we write the code for this? Let's try to write it all out in one go. Otherwise, going back and forth will be annoying. Good. Here, we first need to find this connection, because without this connection, we can't do anything. You can add some appropriately. Some misjudgments without links, etc. because what you said might have timed out. Or some other situation. Let's not write it so complicated. Then we judge the current state. It must be this tick state. If it has already entered another state, enter recycling, enter the closed recycling state or timeout state. You cannot do such a thing. If it is the tick state, then first, we let our server side refresh our heartbeat. Let it return to the 0 timing. Then we should prepare a message. As for this message, its coda must equal 0, 3, and its action type means the server returns it, because the message sent by the client is this. Then the response tick returned by the server means the server tells you that we have received this tick, and you can also refresh your tick on your end. So this type is like this, and we definitely have no data either. Then at this point, we just need to simply send it. It's still relatively simple. You see it's written very clearly. Then next, now we are about to enter the third phase. That is when the client sends a message to the server, and this message, we don't know how to handle it. Because this message is from the user, we expose it to the user. It could be sending audio, it could be sending images, it could be saving some data, those kinds of data, so we don't worry about it. So what do? We just need to pass this information on to the blueprint. Of course, the blueprint here isn't necessarily a blueprint. You can also receive it. No problem. So to make it easier for everyone to understand, well, just throw it too. We'll just throw this information to the blueprint. Because this information has already been encrypted and decrypted by us, we just need to throw this data out. Okay, now a bit more complicated is that we have logged out here. The requirement here is that the client wants to close this connection. So the client says to the server, I, the client, I am client player A. I want to exit the game. Please close it. Then the server will receive this information. So the server receives this information. That is to say, then what is the information it returns? It is still the same. The information it returns. That is to say, it can directly let him exit with such information. That is to say, I have now received it. Then I set this status to exit. Then we give him a message, and our message is our server allows exit. We have already received this. We have already changed our link status. Then we left this message. Then we cannot directly close this link here because sending data takes time. You cannot directly close this link here, because you might not have sent it out yet. You would have closed the link, and because we have already adjusted it to exit status here, then we just need to patiently wait for the heartbeat mechanism to remove it. So here, we need to wait for the heartbeat to remove it. You might ask, what if it ticks again in the middle? But you will find that his state has already changed. He only updates the heartbeat in the tick state, so he does not update the heartbeat in other states. Other states will be recycled through this heartbeat for the first time. So the handling here is quite special. I want to emphasize one point to everyone. So that is why this code was commented out. So you can take notes on this. I think I won't go into detail on this anymore. Then in this case, we can see when this is the client allowing the server to exit, this situation is when we want to exit. Our server wants to exit at this time. Then it is equivalent to the client sending a message. That is, I have received the server. You can exit now. So at this point, we no longer need to prepare. We just directly find our link. Then we change the status to exit. Then we just release it directly. We just need to kill it direct because the client already knows you want to exit. You say, here you just kill it directly. This part is a bit confusing because on the client side, we will write it in reverse. When we write it in reverse, that is when we receive this part on the client side will be written in reverse. Why is it written in reverse? That is when we are the client. When we receive a request from the server to exit, we will return to the server. The client allows the server to exit. Then when we request to exit, we will receive the server allowing the client to exit. Then when the server allows the client to exit, we, the client, directly kill it, and that's it. So this part is a bit confusing. It involves two exit mechanisms. Be sure not to mix them up here. These two things are two different exit mechanisms. Actually, overall speaking, we only have 1, 2, 3, 4. We have 5 types of communication. We have 5 communication methods. The first one is highlighting death. The second one is heartbeat. Then the third one is user information, interaction. Then the 10th and 5th are 2 different types of push methods. Basically, we'll just merge it simply here. Our server-side code should be mostly finished. Actually, everyone must be feeling dizzy and tired. because this is a very special way of writing in C++, since there might be no one in the market writing code this way. Yeah, but it is really cool and impressive. So everyone should adapt to this method. Okay, next, we will pull up Postman to test it. Testing might be a bit more troublesome. I think I'll prepare a few for everyone here. We'll take a look later, put them into the project. What else should I put in? Prepare a few shortcuts for him, if you want to test it at this stage. Okay, at this point, we'll add another interface for everyone. Also add this interface to this location. This interface is not something we always use, but sometimes we do use it. That is, when we are in this state, if we have a DS server and we want to get the port of our DS server, this port is not our communication port. This is the port of the game server. So how do we get this port? So obtaining this port depends on whether it is successful or not. That is to say, it must be under the condition of a dedicated server. We go through the world context. We just need to get the exposed port of this game server. Okay, let's bring in a log here. Well, let's first ensure it compiles successfully. We'll test it for you in the next lesson. This port won't be used in this chapter yet. It might be used in the next chapter. Let's just leave it here. Let's compile it. Alright then. Well, that's all for this lesson. In the next lesson, we'll guide you through testing it. Thank you everyone.